Hello friends, welcome to my channel Science and Happiness. After a few days of interval, I have come to you to give a conception of physical and chemical properties of matter, which is an important chapter of class 10. In my previous class, I discussed about the chemical calculations by the conception of atomic weight, molecular weight, mole and molar volume, etc. Now the chapter physical and chemical properties of matter deals with the chemical character of compounds. What is chemical character? What do I mean by it? The ionic compounds or the covalent compounds. You know, ionic compounds are formed by oppositely charged ions. As for example, if we take NaCl, Na plus and Cl minus, most of the ionic compounds, as you know, are composed of positively charged ions and negatively charged ions, and they are ionic compounds and they are electrolytic compounds also. Now, what is electrolytic compounds? The compounds which are dissociated in water solution or in molten state to form oppositely charged ions, and by the application of electricity which moves towards the positive plates or negative plates or the electrical source, and thereby form new compounds, new species. As for example, if we take NaCl, NaCl solution or fused NaCl contains huge amount of Na plus and Cl minus ions. Now, when we dip two electrodes, what are electrodes? The positive and negative ends of electrical source are called electrodes. Now, the positive plate or positive electrode is called anode, and the this is anode, and the negative plate is called cathode. You know, I have come to the chapter electrical properties of matter or chemical compounds. That means simply electrolysis. Again I say, what is cathode? The cathode is the negative plate and anode is the positive plate. Before I am going to discuss electrolysis, I first give you the clear conception of electrolytes. I can say electrolytes are those compounds which are dissociated into oppositely charged ions, and that means plus ions and minus ions, and by the application of electricity which are dissociated and produces new species, mostly ionic compounds. That means the salts, inorganic salts, acids and bases are ionic compounds and they are electrolytes. As for example, all the mineral acids, as for example H2SO4, HCl, HNO3, the bases NaOH, KOH, all these are electrolytes. And salts like NaBr, KCl, NaNO3, etc. All these are ionic compounds. Now what happens when they are in molten states or in solution? they produces oppositely charged ions. NaCl, as for example, produces Na plus and Cl minus. Now I am going to discuss electrolysis. Again, these electrolytes may be classified into strong electrolytes or weak electrolytes. So the electrolytes are classified strong electrolytes and weak electrolytes. What are strong electrolytes? The compounds or the electrolytes which are highly dissociated or which produces maximum number of positive ions and negative ions in the solution or in the molten states are called strong electrolytes. As for example, H2SO4, HCl, HNO3, all these are strong electrolytes. What are weak electrolytes? H2SO4, NaOH, NaCl, all these are strong electrolytes. And weak, which ones? The compounds which produces not so much number of oppositely charged ions are weak electrolytes. As for example, CH3COOH, acetic acid, it produces CH3COO minus acetic acid. This is a weak electrolyte. Why? Because in water solution or in aqueous solution, it does not produce maximum number of CH3CO minus or H plus. That means it does not dissociate completely in the water solution. It dissociates it only partly, but only to a fraction to oppositely charged ions. So it is a weak electrolyte. Now, what is Arrhenius' theory about electrolysis? Arrhenius told that in molten or in aqueous state, all the ionic compounds are dissociated, and when electrical force or electricity is passed into the solution or into the molten state, then the oppositely charged ions move towards the opposite character of electrodes. So cations goes to cathode and anion goes to anode. Anions goes to anode. So for NaCl, first it dissociates into Na plus and Cl minus, then Na plus goes to cathode because it is a cation and cathode is the negative plate. So cation will go to negative plate or cathode, and there it will accept electrons. So Na plus will accept electrons from the cathodic plate and will produce Na metal. So what we will see practically we will see Na metal is deposited on cathode, and on the contrary, Cl minus is negatively charged ion. It will move towards anode, and you know anode is the positive plate, so there is the scarcity of electrons. So Cl minus will go there and give up its electrons to anode, and it will produce Cl atom, and now the two Cl atoms will combine to form Cl2 molecules, and it will evolve as gas form in the gas Cl2 in the anode. So if we put a glass jar on the anodic plate, Cl2 gas we will get. Now we will come to one important electrolysis process, that is electrolysis of water. You know, pure water is not a good electrolyte, or pure water does not conduct electricity. So if you, well, can you give the explanation why pure water is not a good electrolyte? Okay, you will think of it. I am telling you, because H2O molecules are covalent molecules. Though polar, it does not dissociate into H plus and OH minus ion completely when it is in pure condition. If only a small amount of acid or base is added to it, then it ionizes heavily or highly. So in the ionized condition, H2O is dissociates into H plus OH minus ions. Now you know H plus is cation, it will move towards the cathode, H plus will go to cathode, and OH minus, you know, it is negatively charged ion, it will go to anode. Now what will be the cathodic reaction? In the cathode, H plus will take up electrons to produce H atoms. Now two H atoms will combine to form H2 molecules. Now in the case of anode, OH minus will go towards anode and it will give up electron to form OH. Now 4 OH radicals will produce 2 H2O molecules plus 1 oxygen molecule. So ultimately, what is the overall reaction? For 4 OH to be produced, 4 H2O molecules to be taken. So 4 H2O will produce 4 H plus 4 OH minus, and then 4H plus will produce 4H, and they will ultimately produce 2H2, and 4OH minus. Now 4OH minus will produce at first 4OH at anode, and then these 4OH will produce 2H2O plus O2. Then what we ultimately get, this will be produced at anode. So ultimately we get 4H2O to 2H2 plus 2H2O plus O2, or by cutting 2H2O from both sides we get 2H2O equals to 2H2 plus O2. Then what we get? From the electrolysis of water we get 2 volumes of hydrogen and 1 volume of oxygen. So ratio of hydrogen is to oxygen at the two electrodes is 2:1 volume ratio, but it is not the weight ratio or mass ratio, because 2H2 has molecule weight 2 into 2, but the mass ratio of hydrogen is to oxygen will be 2 into 2 is to oxygen is 16 into 2, 2 into 16, or equivalent to 2 is to 16 equal to 1 is to 8. This is the electrolysis of water. You know, the system or the instrument in which we make electrolysis of water is known as the voltmeter. Remember, you will never confuse it with the voltmeter. In the voltmeter, we measure voltage difference or potential difference, but in voltmeter, we perform the electrolysis of water. I think you are very attentive to the class, and I think you have a larger concept of electrolysis. Thank you. If you like the class, please share it to others and press the bell icon and subscribe the channel. Thank you.